Let's go. Okay, we're on. Yeah. So, what we're doing today? Well, yesterday, what I did basically was I was going over this. Just give me a second. This perhaps should be a little bit quieter. Perhaps. I was going over this, the CVE-2022-32250, right? And we went over the parts which were about the heap address leaking and the cache leak. And I'm following this write-up of Theoria, by Theoria. And I went into hours over like the structures we're supposed to use, how we're supposed to use it. I wrote down some notes, and yeah, it was really 2 productive hours of research. So what we're doing today is we're going to be looking into how they actually escalate the privileges, and then we'll try to replicate their exploit. Yeah, I'll try to replicate their exploit to some degree. I might, honestly, I might even look into another way to escalate privileges, which is another mode probe path override. We'll see. We might do some interesting stuff here. Yeah. But generally, that's what we're doing today. And yeah, that's pretty much it. So we can kind of recount what I did yesterday, right? So I went over how the vulnerability. What exactly is it? That it's a use after free, where you. This is way too loud. What the hell? That it's a use after free. That maybe it's not the right moment when I'm talking. Yeah, it's a use after free, where the lookup expression after it's allocated, if a certain flag is not set, the stateful flag, it will be freed and destroyed. But the set toward but the binding from the set it's looking up into won't be removed. So the expression will still be binded to the set. And this is pretty much the vulnerability. It's a use after free. And what we do to rig the heap address, we just target, like we create 2 use after freed objects, because they are both binded to the set. The first one holds in a next pointer to the other in a linked list. And if we allocate 2, and we allocate the user key payload object over the first one, we can free read the heap address of the second one. That's how we rig a heap address. And the rigging of the KSR leak is a bit more complicated. Like a bit more complicated. So what we do there is we use a POSIX message 3 node, which basically handles multiple messages, which are like strung together. And yeah, so we allocate first a user key payload, the expression which is freed, and over it we allocate a POSIX message 3 node. And then what happens is the linked list of the POSIX message 3 node matches the binding linked list of the lookup expression, and now the POSIX message 3 node points to the second UFID user after feed object as its message. And this second object is probably not a message, but it points to it as a message. And it points to it because they were both in a binding to a set. And this address here is set by NF tables, by netfilter, to point to this address here. Just because that's how the bindings work, because all of the expressions that are binded to a set are in a linked list. Yeah. And what happens here is the function doMQ time to receive thinks that at this address it's the first message, but it's actually not the first message. We allocate the user key payload there, and we basically start leading. And it thinks that this matches to the start of our message structure, but it doesn't. And we allocate the second object right under this one in the same slab space. right under this one. And what happens there is that it thinks that at data 5, which is actually the beginning of the next object, which is also a user key payload object, at data 5, which is the next one here, which is not in the graph, but it's the next one, it thinks it's the next point of the linked list, which is good for us. Oh, it thinks it's like, no, sorry. It thinks the next one here, data 5, is the security pointer, which is good for us because when you free a message, it also frees security, the security pointer. So it is important for us that it's a valid pointer to memory that can be freed, you know. So yeah, and because we allocate a key user payload here, the first word of the user key payload is a RCU head, which is a callback head, and the callback head has an X pointer to it, which is a valid pointer to memory. So it actually, when it frees security here, it will free the callback head next. Yeah, and then what we have right next to it here, like after the next pointer, voice crack. After the next pointer, I'm a little bit sick, so my throat is weird. After the next pointer, we have a function pointer, which is a text address, right? And what happens here is that if we read after it, because we can read after it, because after the security pointer, the actual message follows. So we can read after it. If we read here at data 6, we'll actually be reading the start of the second user key payload, or not really the start, but like the RCU function pointer of the second user key payload. So you can read a text address to that. It's a little bit complicated, but here it's summarized basically. How a user key payload overlaps with message struct. So data 0 is message mlist next. This is the data of the user key payload here. So all of these match, they match to certain like parameters of message, and then we have one user key payload allocated right after our first one, and here the RCU next is message security. So when we perform key-free security, it will not throw an error, and the next one, RCU function, is the actual message data, quite set was set, the header is the beginning. So if we read from the user key payload after we do all of that, we'll get a text address to which we could actually reliably leak KSLR, and we could defeat it. So that's pretty much it. That's pretty much how all that works. Has this team been going? Yeah, 7 minutes. Holy, time passes quickly. Okay. So that's pretty much it. This is a very quick summary. I recommend just looking over the VOD from yesterday, which is my YouTube channel, or just here on Twitch. I'll probably link my YouTube channel somewhere. Yeah. But yeah, that's basically my recommendation. Or you can, honestly, you can just read the write-up. Even though it's not very detailed, it's a lot less detailed than my explanations. Or like, maybe not a lot less detailed, like more like a lot less easier, harder. So it's a lot harder to understand. Yes. So, yeah. And now it's time to look into how we'll actually escalate privileges, and then maybe we'll start writing the exploit. And I'll probably use... What happened? Oh, I was in... Yeah. I'll probably use my old exploit for this vulnerability, because I already have an exploit with functions, with helper functions written for netfilter. So I'll probably like copy those helper functions here, just delete the actual exploit content, like the actual exploit, but I'll use the same helper functions, kind of. The ones that can be used, like to create a chain, a table, etc., etc. We use them, of course, because I don't want to write all that again. So yeah, that's pretty much it. Okay, now let's come here. Mode probe path override. In the message get function, with del on next list del unlinks stock messages from the linked list. In this case, message previous next is message next. Yeah, that is true. And message next is message next previous. Message previous. Let me think. Message next previous. Yeah, that is true. Yeah, okay. So what could we do with that? So first we do the same. We allocate user key POSIX message to node here and user key payload over the second object. Oh, I got it. Basically, because we pick the heap address, we can just await at any address a heap address. And our goal is, I guess, to write a new path for mode probe path. Interesting though. Let's see. I'm a little bit confused on how this would happen. I guess I need to look into the mode path structure. Key mode. Reference in key mode. Let's see. Okay. Interesting. Wait. I'm a bit confused here. Okay. Therefore, we can write at any kernel address. Mode probe path contains has been mode probe initially, so if the data 0 and data 1 have modified structure as mode probe plus 0 1 minus 0. What? Huh. This is the temporary directory. Maybe I'm missing out, but maybe I'm missing something very simple here. I'm a bit confused in what they're doing. Like, contains has been mode probe initially, so the data 0 and data 1 have modified structure as mode probe path. Hmm. Let's see. There's not an article on this. I thought we'd kick things off. Yeah, but if we have the other show the multiple path symbol, how do I direct into it? Am I dumb? What? What allows us to just... Oh. Wait. Wait. Here data 0, data 1 is the previous, so I guess we overwrite one of these, and then the next points to the... I don't know, this seems a little bit weird. Next points to the... Okay, let's first read about the technique, then we'll get into how we actually exploit it. Yeah, when I know about this, how this works. Okay. Oh, I have highlight. No, what? Sensitive. Yeah, I think I've taken a look at that. But I don't remember, honestly, much. How can I save it into that? Oh, here. I'm dumb. Save it there. It's more important, I guess. Alright, more appropriate. We can call both. We can see the dates of each binary format and formats. For each format, save the file format on binary implementation can process our PRPM, which contains a buffer data of up to the first bytes of the data from our executor. Okay. Okay, got it. Kind of. What do we do? We just have to avoid the path that it holds. Kernel PVT for Kessler, Kernel the multiple path technique. Okay. Pam pam pam. Okay. I got what it's doing. Now let's see how we can export it to our primitives, because that's a little bit more complicated. mlist next. This is mlist next. And so I have message here. This is our message. Message next previous. will be equal to the data 1. Oh, I got it. I think. Oh, I think I got it. But message previous next. To message next. Yeah, I got it. So we write then here. Yeah. Because it's removed, because it unlinks it from the linked list. Here now data 0 holds. What does it hold? What does it hold? Like the function which handles the POSIX message denote. What was its name? I don't remember. Something the MQ time receive. Yeah. It actually thinks that this here is the beginning of a linked list, because this points to it, and the linked list, like it thinks it's a list kit. So it actually thinks that here data 0 is the next pointer, right? Yeah. So it thinks that, and because of the unlinking, now the message next previous wait, message next. No, never mind. Hey. Wait. The message next previous will be equal to the message previous. Yeah. What the hell? This thing. So message next previous here will be just, it will just become message. What the hell? But it thinks this is the message, so it will unlink this. In the message get function is the unlinked stuck message from the linked list. In this case, message previous next equals message next, and message linking occurs. But that's for the other. Oh. Okay, so message previous is this here, and next pointer equals the message next pointer, which is here, like this here actually. So if we I got it. I think I actually got it. Okay, we write in data 0 the multiple path address. So now when the unlinking happens, it fixes the rest by doing a thing where oh, I don't know if you can hear that. It's fucking yeah. Just give me a sec. Okay, so what actually happens here is because of the unlinking, the message previous, which is this data 1, which actually points to this, it will write it so it points to the address in data 0. So what actually happens is the address in data 1 will go in the address that is the address in data 1 will go in the address of UF2 plus 018. Like 018 as an KX18. Yeah. This is what will happen. Because this is the message, right? And it's previous, the next pointer of the previous one, and the previous one is here, this is its next pointer, will now point to the next pointer of the message, which is this data 0. Yeah, okay. So what actually happens here, not what I said a second ago, I confused it a little bit. Now data 0, the address that is data 0 will be written here. That's what I'm basically saying, I think. Let's see again. The address of the previous one, which is this, its next one will be written as the message next, which is here, this here. So yeah. So we in data 0, which we can influence because it's a user key payload thing. Here we're just basically going to just write the address that we have, and the address of the multiple path that we've calculated from like the kernel build, and because we leaked the heap address, so we have the heap base now, right? So data 0 will point to the mode probe, and then data 1, when it links it, it will be like, what is the previous object? It will look at data 1. Data 1 will point to this, and it'll be like, oh, okay. So I'm gonna point this previous object's next one to the next of the message that I'm unlinking. So I remove it from the list and I stitch up the list, right? So now data 1, data 0 address will be written here in UF2 plus hex 18, or like not in UF2 hex 18, it's in UF1 plus hex 18, but they write it as NAC with the address here is UF2 plus hex 18. But yeah, this address that is here will be written here. Okay, that is clear. Okay, this is how it actually works. When it's here, however, what happens now is that this function do MQ timed receive will point to it. And what happens? How do they overlap? How does the message overlap? Like, what do we do here? Interesting. Okay, let's write on this type. This. Is it? What was? Yeah. Yes. Let's play some music. Why am I writing this shit? So is it not like? Yeah. Nope. Someone followed. Thank you. Yeah. I don't know if you're in chat. Props not. But yeah. If you can say something in chat, I don't know. Not a streamer guy. I just do it so I can focus more. Yeah. I'll copy the graph again. It's really good. But I might edit some stuff out now. I don't know, probably not because it's too messed up. But okay. Due to how a linked list. No, first message get unlinks a message from the linked list. Due to how unlinking works, it will linked lists make. So we have message next, the message next previous, the previous of the next one here. So the previous of the next one will be equal to message just previous. So I can stitch it up on the next side, and then we need to stitch it up on the other side as well. So now message previous next we'll just point to message next. So you can stitch it up there as well, right? This is correct, right? Previous next is message next. Previous next is message next, and this next previous is just previous. Okay, this is how stitching up works. So if we write the mode probe path structure address that we should have, because we leaked the heap, leaked a heap address, and we can calculate the heap base. I think I'll just move this. Have the mode probe path address, because it have, yeah, okay. And now at the end we need to just move this one at a, yeah. So if we write the mode probe path structure address at date 0, after the UF2, which is a key user payload, but what is this function called? No, but get message, or should say get message, believes it is message. Is unlinked, linked UF1 0.18. Hold the value of data 0. Now we can full the again write an arbitrary address, that of the mode probe path, to POSIX message 3 node. That, I think that's what it's called, right? What is it? POSIX message 3 node dot, and it's next. No, what is it? Where's the POSIX message 3 node? It's message list dot next. Okay. Not here. And for the message functions to believe that mode probe path is a message. Now we just have to figure out how we'll actually write this. Because fine, we overrode the address, but how do we actually write into this address now? What? Because we have, okay, we have a primitive, now it thinks it's a message, but how do we write into it? Oh. Hi, I want to offer a perfect channel viewers to the price. Okay. I don't care. I don't care, my guy. Incredible, flexible, and convenient order management panel. Everything is in your hands. Chatbot. I don't. What is this? Promotion of your channel. Is that just boating? I'm just offering boating. I'm pretty sure. Okay. I don't know. I'll just time out because I'm not even sure it's boring, but I'm not going to that link. So, yeah, I won't ban you. But I'll time you out. Nah, actually, just advertising. Never mind, I'm banning you. Bye. Okay, let me just message. Just give me a second. Okay, let's look into this thing now. What is it? The multiple path. We know it basically holds like address, right? I don't care about any of those. I actually just want. Okay, send char multiple path. Game mode path length. Is that the length of this that it can hold? Perhaps, I don't know. 256 maybe. Who cares? Now I'm more interested in how the fuck we're going to write to it. Because okay, we fooled PostFix message 3 node to believe that it holds that this is a message. But what do we do now? We can read from it for sure. But how do we write into it? Okay. It says, oh yeah, that is true actually. Wait, okay, we can influence. Wait. I think they're hyperwrite here. This is a way to actually just write it here, but that's not what we want. What we actually want is just to write directly to the structure. And because of how the unlinking works, okay, because of how the unlinking works, if we actually like write, how long has this thing been going for? 36 minutes. Okay. Message next previous will equal message previous. So if I fool it to, oh yeah, that is the way. Here we are. I can fool it to believe that it's writing into a message structure, but it's actually writing into a mode path. Okay. So we can use the unlinking to write directly to mode probe path and what path up to can write up to 8 arbitrary bytes. Right? Yeah. How do you do that though? So data 0 is the next here. So to write, oh actually we want to touch data 1 first. No, not even 8. I think we can write up to 16 arbitrary bytes. Nah, one of them has to hold the mode probe there. Yeah. The previous, the next of the previous. Okay. So data 1 holds the address of mode probe path. Now, if we write, if the unlinking is done, it will write to probe. It will write to mode path the value that is the address / the value in data 0. Yep. Because data 1, what happens here? Data 1 is the previous one. So it actually thinks it's the previous one. I'll write this here. It's message previous. So if it holds the address, multiple path, now it will write to the beginning of multiple path because it thinks it will be fooled because we think multiple path is message previous next. It will write and it will write the data in data 0, the address, like the data. No, yeah, the data in data 0 because it thinks because data 0 the 0 equals to message next. So we are using the fact that during unlinking message previous next equals message next. Or like not during unlinking, but after unlinking. Okay. So that I'm just randomly hovering like that, I'm just messaging on my phone. So yeah. Yeah. Okay, so this is pretty much it. Let's read about this. What is this? We can write in mobile path plus 01. Why? So data 0. Oh no, I messed up. I do it in reverse. Wait, am I dumb? Fuck. Message next. No, it's fine. Kind of ordered. Okay, never mind. They're doing it the reverse though? Am I dumb? So if the data 0 and data 1 have modified structure as multiple path plus 1 minus 8 and the new address. Okay, why is he doing it this? Why are they doing it this way? So they're using the fact that this will be next, they're adding to the previous of the next, but they're subtracting 8 as to not like fuck it up, and just citing. What the fuck? They're subtracting 8 because they believe that the previous pointer is equal 8 bytes offset, which is offset from the start, which is true because it's next previous, not previous next. And make lists. Yeah. Let me think. So let me think what they are doing. So data 0 here holds next. So they're putting to the previous to the next. So 8 byte offset, but they're subtracting it, so they're matching it. Plus 1 to like probably escape the back, not escape, but like don't rewrite the backslash, like the slash. So yeah, they're probably doing that. Okay. So now data 0 for them holds the address, and then in data 1, they're writing the previous. Not the previous. In data 1, they're writing the thing. What I'm thinking we had by speaking. What is this? No. Why is this singing? Next, please. I want an instrumental. Next, previous. I write the message previous. Okay, I feel my case works. Their case seems to work as well. But now that makes me think, won't that fuck it up? Won't that, like, major fuck it up? I don't think it matters actually. Both work. Never mind. I think both work. The only thing that could get fucked up is that now it will try to write into this address, which is non-existent. The address of data 1, the previous address. Try to write in the next of the previous address something, which might crash it actually. Just real concern here. How the wait, why does it not crash? I don't think this follows anything. That's a good question. Because it does double. It writes both the next and the previous. Not only one, them both. I don't think. Maybe it will just throw an error. But then we have to make sure that we're writing. That our writing goes first. Let's actually look into what it does. What the function does. Yes. Let's look into that. They said it's message get function. POSIX message TV. Yeah. And somewhere here, when we get the message, we do the unlink, right? Here is though. Which one? This one. What? Why are they doing this though here? If they believe that the list empty does not return true after this, then it is an undefined state. Is this a phone? Why am I really dumb? Because they're fucking up the rest here. Yeah. Am I crazy? Aren't they doing something that's written in the documentation? As in not to be done. What is this fist poison shit? Oh my god, there's so many jumps in these functions. Next previous equals previous. Okay. And then right once. Previous next is next. So it first writes the next one. I want to actually see this. Maybe the structure, the POSIX message tree will never be deleted. Maybe that's actual vulnerability right there. Who knows? I'll look into that. I have to remember to look into that. I don't think it's a vulnerability, but it might be just a little bug. It's 100% on the phone. Never mind, I'm just insane. It's just a bug. If it's true, if the vest cannot be confirmed as empty after that, because it has undefined behavior, like undefined state. Yeah, perhaps. But first it does next previous equals previous. And after that, I think I'll just do. Maybe it won't actually. Maybe it'll just write to that randomized address in memory. No, it won't. It's not that lucky. Huh. Writing to address error. I think, yeah, it might just give you a bad address or something, but it won't crash. But for sure, we have to write first next previous before. So, is the way they're doing it? Well, it's probably correct. Because they're writing to the next previous one, the previous one. No, wait, yeah. The next previous one, the previous one. So we have here, this is the next one, right? And we'll be writing the previous. Oh. The next, yeah, this is correct. What am I doing is the opposite. I'm writing to the. But, okay. But this has to be Rust and write. Just give me a second. I need a second. I'll be right back. Okay, I'm back. Yeah, let's see. So, first, and write first, and write the mode probe path to data 0, and the path to data 1. That's because whenever it is deleting an entry from a linked list, the kernel first does what happened? I heard a notification thing. What? Wait. The kernel first does next previous equals next, right? No, next previous equals previous. Before previous. It's interesting that only this is in the right ones. So I'll just include the snippet here. Okay. So if we do, if we do it other way around, oh, throw a bad address error before it writes. I don't know, right here maybe, because I'm not completely sure that's true. Prefers to write multiple path to data 0 or writing multiple path to data 1. But here we have to include that it's -08. -08 because it's taking the pref the next just 8 bytes offset from the start of next of start of mode probe path. I don't know how to write this, but I think this makes sense. Because it is taking the pref of the next, the previous to the next, which is 8 bytes offset from the start of mode probe path. Okay, this is too many next and previouses, but it's fine. Essentially, we got it. It's doing what we want. Like, we got how it works. Yes. Okay, now we basically have this down. Now, I think we can actually start to write the exploit. I just want to see one thing. I'm not even sure it will crash, or throw an error, or just like kernel panic. I don't know what to do. And if there is a fork here, wait, let me see. I just want to. They're kind of. They're okay. What is sema down? Sema down. What is this? Sema up, sema. Ah. Semaphore? Is it just a semaphore? I think so. Why are they using a semaphore? Where do they need a semaphore? What? Oh, they are fucking here. Yeah, they are. They need a semaphore for this. So I guess the fork is needed. I don't know. When we start writing the exploit, I don't think we'll finish the exploit today. It seems kind of complicated. But when we start writing the exploit, we'll actually see what is happening. But yeah, this is pretty much how the purchase occasion should happen. It's not complicated. Seems kind of easy. Okay. We can now kind of start. So I'll open a new file vim exploit here. But I might do something like research the old CVE and do code here. Open the VS Code for the old one. So I can just like copy code around, I guess, from the previous one, because I have all the helper functions here that I probably need. We'll probably need. Yeah, what is happening? Is my CPU literally dying? What is that? No. Side to top, I guess. Okay, I don't know what's happening. It's just phasing for a second. Just copy all the headers. It's probably gonna need most of them. This export was a lot longer. It's like not a lot longer, but significant amount longer. Setup table and chain stuff I'll probably need. But let's actually look where we're starting from. I don't know how good this is, but yeah, okay. First, we need to leak the address side. So, what we need to do here is basically create a table and a set. Create a table and a named set. After that, we just add once lookup expression, or like NFT lookup, I think it's called. Yeah, it's called NFT lookup. Without stateful flag, so it is, and then add allocate user key payload over it, and then add another NFT lookup. Without it can have the stateful flag, honestly. I don't think we care at this point about the stateful flag or not. It can have the stateful flag, but we'll say, yeah, okay, I have to look up or to the same set, the same table name set. Okay, so let's start. Have some in between. Shit. Okay, so here we're going to have function, which is gonna be, what do we actually need? This function which allocates, it setups a table and a chain. So void setup table and set in our case. But it does need a chain as well, I think. I think they'll be different, honestly. I'll separate them in different functions. I'll have setup table one first. It takes table name. And a hook number. No, but the hook number is from the chain. We don't need it for the table. It just takes table name. And this is basically the table setup shit, which you need. What's happening here? Okay, let's look to again for a second. What is this? What? Was that just a rendering thing? I guess. happens sometime. So now we need a few buffers here. Need this buffer. I'll just copy all of it and just remove whatever I don't need. Oh, I'm so glad I can use these functions, holy. Because when you're writing it the first time, you basically only have the fucking NFT tables. Is it even the NFT tables or just, yeah, it is the NFT. The NFT, what is it called? A Vib NFT nil. You have only this thing to use. And this has like zero documentation. Just has examples. And just for one of these examples, which kind of does basically the same thing. But yeah, have to kind of, yeah. Okay, this is not needed, I guess. Why is this board ID used? Oh, it is needed. I'll leave it in there. This is definitely not needed. Table sequence needed. Change. This is not needed. The family I think is needed. And is it tables belong to a certain family? I think it, right? Yeah, they do. Okay. Wait, what the fuck is this doing? Why does it get the family back? I'm never setting the family in the first place. What is this? Fuck. It works. This exploit works though. Is this something I've just fucked up a little bit? Yeah, here I said it. Then photo. I guess I just missed it there? I just worked all this time? Oh. I guess I don't need it then if it worked. I guess it has a default family that it sets. I don't know what happened. Okay. I'll just leave it like that. We'll set up here sockets, table batch. Let's see from error adding table. Oh, table created. This is all I need. And I think this function is actually done. Also, kind of didn't talk about it at all, but here, let's exit this. Here I have a. This is the same VM which I was running when working on the other vulnerability, the one I have on my blog. Yeah, I've written up this one. When I was working on this, is the same. It uses I think 512, right? Yeah, 512. It should be vulnerable to the same vulnerability, so I'm just reusing it basically. Yeah. Yeah, we can do that. Because why? Because I have everything here basically. I have the modules, the Linux modules important. I have a build that I've set up, like a file system, everything set up. So I don't have to spend like an hour setting up everything, building the kernel from start, etc. Oh, hello, what's up? You watching? I finally have a viewer going to name the show to spam me about botting. Yeah. Because this guy just came in and was like, oh, you want to bot? Yeah. And we have to close the socket after that. I'll just hide that. I guess. Wait. Oop. Now socket close. Now so this should basically work. We can test it out, but it takes a lot of time to actually. I'll just do a lip stage export just to see if there are any errors. It did. So I have to fix that. Oh, we have table add pass, which is also a function. This is why I'm setting the family. I got it. This is why it was so. So I am setting the family. I'm just dumb. I just did it in a different function for some reason. I don't know what the. Yeah. Where's my thing called? Let's see here. I just drop this here. This function I have from the other exploit. I don't think I'm going to do this now. I think I'm just going to. Yeah. I think I'm just gonna add it here because I don't get confused like this again. And now we're just passing if net here. Then pass the paths, the family. I think it's better code. Better code. So, whoops. Oh my god, web stage exploit. Okay, I'm not gonna wait for it to do it because it's just long. I thought I deleted those. What? I have the oh no, I didn't. We don't need the batch chain stuff here. And we definitely don't need this. Yeah, okay. No errors, it's just building the custom. Hello, trash girl. In here? You might have muted it in the background. It's out of visual fucking glitches. I don't like that. But it's fine, I guess. Yeah, now it's rendering fine. Typical Vim, new Vim. Nishta, be like. Yeah. Okay, we're good. So this just builds stable. Do we want to build a chain? Can we have a set without a chain? We cannot have an expression without the rule and a chain, so we do need to build a chain as well. I guess. Do they have a default chain? I don't remember. Let's see. I don't remember at all. There's a chain add stuff. Just want to see somewhere we're adding. We can add an object like a set. So the set does not need. Yeah. If you look at it, I don't think it does. The set is not table agnostic, but it's like chain agnostic. Because it just cares about the table, I think, right? Yeah, just cares about table. But we cannot add an expression, lookup expression without it, because it has to be executed in a chain, right? And in a rule. Yeah. F. So we actually need to allocate the chain. Well, fun. Yeah. Okay, I'll just have. I could have just copied the entire thing actually. They've set it up. Set me up with the default chain. You know what? I might actually do get at. Yeah, who cares about the one? With commit. What? Git commit. I'm committing, so I just have separate table function. I might just use it. Yeah, I'm committing so I can get diff after that. But now, basically all of this that I was doing until now, we'll just, yeah, I won't actually visualize, never mind. I was just, yeah, gonna do this, copy this, have to do the thing I did a second ago. What the fuck did I write? 16T family infinite. Yeah, also this will hook us up with the table on a chain. Even if we don't use a chain, it's just useful to be in a, yeah, but just easy to be in a single function. And now let's actually see how this, yeah, I forgot. Here. Excellent. Cooked. Okay, we're good now. No arrows here. No arrows here. Good. Now, the thing we actually want though is we want sets. And adding sets is a little bit different, I guess. I don't even know how to add a set. I didn't need to do it to the previous vulnerability. So, let's take a look, I guess. Where's my... This. Is this... Nope. Is this an object? Oh yeah, this is it. This is how we add the set. No, this is just how we add a single object. Never mind. We don't add the set like that. Never mind. This is it. This here. Set add. Oh yeah, this is it. Set. Yes. Oh, we know what we're good doing. We're just stripping this function completely because it's in the example and we can just use it. And it's going here. Yeah. What do I have here? Here, okay. Family. It's 8 here? I thought it's 16. Wait, family, I guess it's an enumerated one. And it just needs to be, it's just an enum type. It just needs to be as big as values go. So 8, 16, who cares, I guess. Just like 6 files, I think. IF, IPv4, IPv6, IFnet. Which are other families? It has one that's like low level. Not low level. Like, oh, I don't know. Let's see. All of them. The one quite to like link level. Have average net def in a type. Yeah, the 6. I just forgot which 6. It's in the article. Yeah. Okay, we have the table here. Killing. We don't care about any of this. I think we just need a set. Just a random set. We don't care at all about the set. So good. I have a set. We just have a. We just need a non-anonymous set. This is non-anonymous because we're giving it a name. Yeah. Okay, perfect. I'm just stripping this entire function as well. The example is perfect here. You don't need to do anything else. Setup, set. Just boom. Now we just need to pass the things it actually needs. What does it need? It needs a family. which is 8, I guess, or 16, doesn't matter. But I want the family to go last, actually. I want first table name, and then the set name, and then the family. I think it's fine. No, it isn't. I guess both are named setups that I just realized. And this would just be add set, I guess, because it actually adds the set, it doesn't just set it up. Out of arrows here. I haven't imported something. This one, this header, I think is all I need. Where am I? Netfilter here. It's very clear in add set. Oh no, I'm recording. Okay. Yeah, okay, we're good. We're good now. So this function just add as a set. Now, what else do we need? We need something that adds actually the expression. And then we'll start debugging a bit of it. This adds us a set and everything. Those functions. A table, a chain, and a set. I will need to add an expression and to add the rule. This is where we get this. I guess I have to set it properly, but we'll just add the exit. We'll just call it setup lookup rule. I don't know what the fuck to call it. Doesn't really matter. Just holder, like placeholder rule. No one cares. But yeah, I'll just call it static struct nft name rule, and then we call it lookup rule, which is kind of dumb because the lookup is an expression, but it is what it is. The board is needed there because I was checking against the board. I don't need it here. Static. Oh, that's static struct. I need to take a break in a bit. I'm just feeling a little bit exhausted. Kind of sick still. So yeah, this is just copy this. If I am actually on the grind, I think I can finish the exploit today if I'm lucky and everything goes to plan. But I'll probably have to like code like 8 o'clock and like 5 more hours maybe. Yeah, probably. We'll see how it goes. Now, we need something that actually adds the expression, like these, right? And to do this, you need to come. What did I open? Oh no, I just switched now. We need to allocate a lookup expression and static void add lookup, and it takes all the same. What does a lookup actually need? What does... Let's look at the notes. What does a lookup expression actually need? Not here, where is it? Why does the music sound distorted? It needs a set. How do we pass the set? As a name? Or does this... No, it doesn't return an ID. Oh, do we actually pass this a... That's a very good question. We need to look at some stuff here, I guess. I don't know how we pass it. So, lookup. Search for lookup. It's set of set ID. We can use both. I think I'm gonna use the set ID because I think I anyway pass a set ID. Oh no, I don't. I set the set ID here to 1, which is a problem. I think we'll pass set ID. I think it will be easier to use the set ID. I could just use a name actually. Fuck, I'm just using a name. Shit, I don't have to edit functions. And I don't want to. So we're just using a name. Okay, so this needs a set, which is gonna be a char pointer. Yeah. So like dvec, I don't really care about those. I think they can be anything. We're not going to use them actually. So I'm just gonna have to call them for now. If I need them later, I'll just, yeah. What else do we pass? Flags. No. No. This is all I pass now. Oh, but do we actually, I think we need the flags. We need to pass the flags because I want to. Okay. If I had deleted something here. I don't know what's happening. It had a source control thing, this, right? What? Oh, this is to commit. Ugh, I hate VS Code. Can I just look at the changes? So I don't have to open in the terminal and git diff. Come on. Actually use this editor. Oh my god. Oh yeah, no. It says there's changes. What? Okay, I'm just going to... Oh, it said it's changes because I hadn't clicked twice. I'm dumb. I just realized. Yeah, I guess. What had I changed here? I had just... This is good. Fine. Yeah. Sorry, I went off the tracks a little bit there. I'll just, yeah. construct NFT expression E. And we allocate it now. It's a lookup, right? This is, I think, yeah. It's just called lookup, nothing more. Just gonna set this first, I guess. NFT expression set. How do we set it as? Do we call it? Have to pass a pointer to the. Do I use data for this? I have no idea. That's interesting. Yeah, I probably do. Oh, we can use set string. Oh, you can use it for here for the set. You can use it also for an expression. Oh, this is the same one. This is literally. This is literally. I didn't even notice. It is the exploit for the same vulnerability. Okay, good to know that I can use it, I guess. Set string. Someone here? Nope. 1-0. Users in chat. No one. Okay. Cool. I kind of feel more comfortable when I could, which is just me, I guess. But the thing was, we need to pass flags because we want to pass that it's not stateful, I think, right? This is one of the things that we want to pass flags. I think. What type are the? I don't know what type they are. I think they're unsigned 34 or something. We'll see. For now, they have that. And we do NFT expression set unsigned 34 E flags. I need deveg and sec, which we're gonna hard code. It's fine. NFT expression set U34. What am I hard coding them to? I think NFT. What is it? Avec 32.0.0.4 and like I think this is fine. And now we just add this expression to the wall. Very good. NFT or add expression and the RE. And here we do add lookup E. Or like we do R, pass R, we pass the set name. We need the set name here. Constant char set name. Then we pass some flags, which also we need. I think we're gonna hard code the flags because I don't care. Okay. This sets up the row, but now we need to add the row, and we need another function for that, one that adds a row. Here. It's basically a function that adds a row. I'm just gonna rip it from my other exploit as well. Again, my PC is once again making very weird sounds. Question mark. I can just pause that. I don't need to be watching it. But here. What is happening? Oh, I was in too small. I just noticed. Now this is a little bit complicated here because of those root types and the way I did it last time. Pretty much everything is the same: table name, base name, root type, but we're moving. I need the key base stuff actually. I'm gonna be passing. No, we're not gonna be passing kernel base like that to an expression. No. I think this is fine. Why is it child? Oh, because it's hyperbole assumed. In no optimization, it takes probably just a char to go to those, not more than that. So I guess I didn't care. That makes sense. Sorry, what? Oh, we do R. This is the wrong place, I feel like. Should be at the bottom. Do a lookup. Oh, okay. And then we're passing a family. A table. Change it. Then I think here. Not to render that, but it did render. Now we also pass a constant child set. Jesus, so many visual glitches in new them. What is happening here? Why is it visual glitching like crazy? Oh. I was clicking Shift 4 to Nyako jump to the end of the line, but it was Nyako like reacting like I'm on an empty line, because it was before I was on an empty line. It was a visual glitch. It showed me like that Nyako went off by one line stuff, you know. Happens, I guess. It's just Vim stuff. I'm used to it. I didn't finish this here. I forgot. Then we delete this because I don't care about it anymore. And something is base chain. Okay. No, you know what? This names chain. This will remain chain name. No, actually, it's just easier to change that because I think I use it more somewhere else as well. There's okay, it compares. What just happened? I'm misclicking some stuff and it's just sending me around. I'm a little bit tired. It's the same thing. I guess I did undo pretty well just a second ago. I guess. I didn't realize I misclicked, I guess. My bad. Yeah. What's the non-void function? Yeah, I do need to return R here. Okay. No else. It works. Nice. So now we add we have everything from table, chain, set, row. We basically, I think we're ready to actually try and see if if a user have to freeze something. Let's go. Now we just need to stitch up everything together. So first we call. Why am I have to say about it? This music is kind of weird though. Okay, set up table on chain. That's what we'll go first. Set up table chain, and we call them char table name. Just gonna put the first table, or just table one. Just table one, please. So it's easy. Table one, just be table one. We'll have another one, which is gonna be like, wait, like chain one. Will be just chain one, and then we have a we have a set one. Should be set one. No, just a little bit dumb, but yeah. Now I just do table one, chain one, set one. Good, very good. I also have to pass a hook number. I don't really care about the hook number here. Which one was the? What were they like? Workout out, NF hook workout out, or something like that. Let's see. NF innet workout out, I guess. NF innet. For our purposes, this doesn't matter. Hook number is irrelevant. Okay. This case the set. This case table on chain. Now we care about the set. Add set table name, set name family. Table name. Oh fuck. Add set table name, set name family. Now I just need to add a rule. Under table name, base name, set, base chain, set. So add rule, table, chain, set. That's pretty much it then. I think this is it, baby. Let's compile. No, fuck, I forgot the flags. I just remembered. Here, those flags, I forgot about them. We need them though. Stateful. And I don't know. What? Wait, let's see. Come on. Nope. Object. I think there should be. Where the expression flags be? There should be an expression of H, but they are not here. I'm just on my phone again, messenger. What the fuck is it? Okay, I think I can just look at the. Oh, it's mentioned in. Wait, I'll just do it this way. We had it here in my notes. Something about stateful somewhere. Right? I have this, which is an set map. I don't care about this. This is another flag. Never mind. This is not the one I'm looking for. The one I'm looking for is something stateful. I remember. Here. Or it's this function. Let's see. Time for boolean. Elixir. Which I'm here. And we basically. I mean, this is the old version. But now it's moved to which function was it moved now? Let's see in the patch notes. Time to look at the patch notes. Table CVE. Expression unit. Why is it? Oh my god. Oh, 2 hours almost. Okay. Unproductive. That's fine. It's here now. If it doesn't have the expression state flag. But that's not even those flags there, I just realized. It's not the lookup flags, it's in the operation type flags. Actually, where do we fuck with the when do we really fuck with those? When do we copy the flags? Testing. Where does it get those flags from? The expression info. What initializes the expression info? It's initialized in this function, obviously. But there was nothing. Wait. Get set from. The info is here, and it does. What is initialize? Ops. Because then from the ops. Select ops. There's some magic here. curious. So how do I actually pass flags? Is it there? Isn't the expression and they just get initiated? Maybe. But that would mean every single expression should have flags like that. Do they all? Nope. It's this one. Maybe actually just this one has it. Okay, we'll try to add it there. I have a little suspicion that it might fail. But it's fine. We can technically just check out where they added. What is wrong with this web page? Oh, it's fine. Yeah, they just admit it, but huh. I guess they just don't set it. Like, they just don't add the staple flag. That's fine, because I don't add it either. Let's compile. Here. We're waiting now. Should I? I'm wondering if I should just do like 30 more minutes of just a little bit of research, and I should go at the day, or if I should grind it until like 5 p.m., like 6 p.m., and actually finish it. I don't think I can even finish it today. Let me think. Yeah, I don't think I'll be able to. But I can, maybe an hour more. Accented quotas. And yeah. It's done. Let's first see if it actually runs. Interesting. Fuck. Which one is that though? I'm kinda chain created, table created. Must be the set. Must be. But I don't even have a thing here. Could it not be the set? Could be the woo. Because we don't have a thing here to tell us if it's the set of the woo. Oof, I think the set should be fine. I just copied it. We just copied their stuff. So I'm just gonna add a real quick thing here. Just going to do. I'm just gonna put def like set created. I don't know, something. Just so we have a little bit of output. And then I'm gonna look here. What could it be? So it's a visual glitch here again. Oof, oh, it's fixed. Dun, dun, dun. Just looking over my code. Maybe real quick here. I think they did the same thing. Yeah, they do the same thing. There's something else though, they add expressions to the set. But that's not a set. So weird. They have a trigger set? Why do they need two sets? Because... It's interesting. I don't think they need that. Oh no. No. Here, just this file. I sort of understand. Okay, let's just check out if it's the VOD set. I'm making sure it's the VOD set. Damn, to be a lot of waiting for this exploit. And I still wanna play some other music. Holy hell! I can only play these for one, so let's play some EDM. Like electro swing. Synthwave? Oh. I think that was synthwave. Eh? It is doing the set. I am. It is doing the set. Huh. So it is the set. Fuck. What am I missing from the set? The hell? Init service type. See NF tables include data types H. Okay, I will see. What the fuck am I supposed to find out? Oh. I don't think it's here. I just have to find it. Ay, ay, ay. Include data types of the HNF tables. Okay. That sounds like the Batman Brave and the Bold music. The hell? Or maybe it doesn't. Kinda does though. Net. Yeah, service type. I don't understand what is messed up here. Maybe it doesn't want the family, maybe it was IFNet for there, but actually what it wants here might be the NF port to IPv4. Might be. Actually. Because I had a problem like that with the last export. It wasn't with the set, it was something else. And this fixed it, I remember. It'd be like that sometimes. Okay, in the meantime, I don't know. I think we need to do. Guess taking a look. What I want to extend to this article. I want to add a thing about sets and a thing about lookup. So probably these days I'll extend this article, cover more stuff, and yeah, pretty much. Are you a moderator? How do you make someone moderator? Because You should be, technically. No. I don't know how to use this. Chat. I have no idea. Sorry. We'll make him moderate some other time. Oh. I just spam it stuff. Oh. What did I have no idea. Nothing else to do right now though. So. Oh, it's a command. I remember. I think, right? No? I thought it is. Is it slash? Oh, it is slash. Okay. Now it's not the set. It said set created and didn't fucking give me this. So it is double now. Or maybe it was the wood and that time I hadn't added the new line. Could it be because it didn't flush this S3 out? Fuck, I don't know. Maybe. But it's something to do with the wool now. What the fuck? What could it be? Maybe I should remove this because I'm not setting any flags anyways. But and we wait again. Yeah, and we wait again. Oof. So much waiting. Why is it not showing me the CPU data? What can I do to... Oh, I don't know. Now it shows them to me. Oh my god. 80 degrees. It is dying. It does not like the streaming. No, it does not. Oof. Oof, oof, oof. Giuseppe is kind of torturing it a little bit. Ay, ay, ay. What is... I thought Giuseppe doesn't use all the cores. What the fuck? But it used only one. Let's make it like less often. I don't know. I still cannot tell most of these people are real people. I mean, they're obviously like not, but like most of them, I don't know about all of you, but for sure most of them are not. Come on, is this done? Fuck, still Still going. I have dropped 0 frames so far. Curious. Yesterday I had dropped like a few. Mistyped. Same fucking thing again. I messed up. I have no idea. Gives you zero information. Like, it's not output anything. Just invalid argument. What is an invalid argument? The fuck? Let's see. What do we actually have here? We pass a expression lookup set, expression debug, and expression seg. That's it. And if you look at, what was it? I lost it. Oh, there was this. No man. This music is so goofy. Jeez. There was like a list with all the possible I remember there was one. All the names, the different expressions. Where was it though? I have no idea. Might be this. What I was using here, I used the NFT nil, not the NFTA, but sometimes I use the NFTA. So which one is it? What the hell? What the hell? Here, there's sometimes NFT nil, and sometimes I use the NFTA. So which one? Here I use the NFT nil. Sometimes the NFT. I have no idea. I'm gonna try with the NFT. Those are the netfilter attributes, I guess. I don't know. The other thing is 15. No, that was supposed to be NFT. Netlink attributes. Is it? I don't know. I really don't. I'm just gonna just copy it. And now we gotta wait again. What did I do? Oh my god, so many visual glitches. I want to like... Oh... Bro. Oh, it wasn't a visual glitch actually. I was fucking it up because I had caps lock on. I'm so used to it glitching visually that I think this is a visual glitch though. I don't care. Oh my god, so many. Why is it happening? Why are there so many visual glitches? Look, this is actually unusable. I don't care. I'm opening in visual. It's time to ditch new Vim in this case. It's my PC still lying. It's a visual glitch after visual glitch. Ah, it's better. A little bit better. What am I looking for? Why can't I see it? Oh, it's here. Oh, true, I have new Vim bindings here as well. Like Vim bindings, not new Vim bindings, just Vim bindings. They're not perfect. It's not that bad. Fuck, I typed WQ by because habit. Ready for my PC to give up again. I hope we don't overheat or something. That'd be shit. Because I'm recording. Doesn't matter, there is a VOD. But still. I'll try in the meantime to... Okay, no visual glitches now. Cool. I think every single visual glitch that arises is from bad wrapping. In my case, it's every single one. But when the line is too long and it cannot wrap correctly. Sometimes it wraps that line to like the next line. Fine, but you do Control U, Control D, Control U, Control D a few times, up and down, and then it's fucked. So, yeah. This is Vim, like new Vim's big problem, I think. At least with my config. What are those buttons? Wait, channel. Manage calls. Start guest star. What is this? Okay, interesting. directories work? What? What do you mean no such file or directory? What is it talking about? Where do I even have directories? What? Wow, it is either problem with the chains or the room. No shit. I will check out their stuff because using the NL ones here. Fine. Oh, they're adding the expression directly to the set instead of like a chain, I guess. I mean, that's an option. I think my way works though, right? Should be. Should work. I mean, it should, but it doesn't, so. I just say something. I'm maybe in good with them. It is table based set. It is family table chain. Okay, not that dumb, I guess. What is this goofy ass music? Okay, time for some Wolfie Pete's. Jeez. I don't know. Can I even? I just realized maybe I don't even need to. I don't actually export anything here. I didn't even need to wait this all this time. I could have just done it locally anyway. I just could have compiled it locally and I don't need even the figure out. Just run it here. Yeah, I don't have permissions. Okay, let's experiment now a little bit. Wanna see usages of this in actual. Oh, no, I wanna see actual usages of this one. Somewhere, please. Usage, please. Nope. Thanks. You can add it to a chain, right? You can add a lookup expression to a chain. You don't have to add it to a set. Because after you run lookup expressions. So what's wrong with my stuff? Something about this, about the way the rule is allocated. I can experiment and actually see. Yeah, I know it's here. It's something about the lookup because this cannot be just like normal way you allocate the rule. I have done it 1,000 times here. For example, here I do the rule allocate. I do each, and I pass as a family. The same thing in if brought IPv4. So it could not be that one, this one, but it could be this. I think it's this. And there's one something more I've forgotten to pass. Maybe. Say ID or flags. Oh, woohoo! This is cool. There's a. Look at this. Wow. Amazing. Okay. Time to change this up a bit. I think we hard coded it to one, right? Where the fuck do I even understand? I don't know. Yeah, it is one. How did I misclick like that? Invalid argument. I am dying. I have absolutely no idea what this shit wants anymore. I'll just give it a no flag as well, just so it stops crying. Imagine if it's that. No, it's not that. I don't think the flags are mandatory here. Nope, not that. Okay, there was only one way to find out. We copy the compare one, and we do here. We do, instead of add lookup, we do add compare. But in the compare, I'm going to literally just up I guess this one is even shitter, because I have to actually pass an op. I don't remember the ops. I was still on from here. And if you compare equal. Oh, I actually have to pass data as well. Nope, hell no. Not doing this one. Which one? Set registered value. This is the omega based one, because it takes the least amount of parameters. Why am I misclicking so much today? Never misclick this much. I have a misclick. Imagine. I need to set more control, I think. And the data here, we still have to pass data. Oh wait, I can do this. No. This is the sheet. And why did it copy the wrong thing though? Another mistake. I guess I'm just bored. What I'm doing, I'm trying to speed on it, but it's not working obviously. My guy. What do you want? Oh, never mind, I'm looking at the wrong thing. Okay, this one works, this one fucking works. So it's the lookup one. there is something so obvious that I'm missing, because yeah, I don't know. It must be something very simple. The thing is, in their exploit, they don't do it like me. I want to add it to a chain, because I already did the chain creation stuff. But they just add it to like a throwaway sit, and they just send the throwaway sit with it. It's kind of shit. I don't like this method. It's not shit, but I prefer to have a chain and add it to the chain. And it should work like that. You know? Do I even need this? No, because it can just be... No! Kill me. It wasn't that a problem, right? It wasn't the fact that I had a it was. It fucking was. The direct. Oh my god. Why would that be the problem? You can have an escalate and a direct because sometimes you want to fetch a key and you want to save the value. In my case it doesn't matter. But why would that be the problem? Still, you want to fetch the key and save the value. And when you remove that, I don't want to save the value. That's when it actually works. Why? That doesn't make sense. Fine, I'm just gonna go with it because I'm annoyed. Ugh. Now I can actually debug stuff. What? What was that? Oh. I don't flush it. I flush this STD out. This STD out. Yep, we're good now. Fine. This is good. Now we can our whip stage, and while it's whip staging, I will be back in a second. I need to take a break, a little break. Be right back. Okay, it's fixed. My headphones glitched out again. They disconnected and then glitches out, so it matches the input and output, etc. etc. It's fine though. I'm back. I want something actually to hype me up, you know? Because maybe this. Because I have like an hour more maybe of work to do. That's kind of a lot of time. Okay, I have this here. Doing event now. We're running this shit. And now we're actually starting to look at stuff. And by stuff, I mean to actually look at JDB and like what is happening, etc. 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 And yeah. I think I'll close this and here I'll open it and here I'll do JDB VM Linux. Here, oh no, I'm not sure if, okay, we have no KSLR enable, we don't want KSLR, or maybe we do we care about, no we don't want KSLR because we're debugging, obviously, never mind, I'm done. Yeah, we don't want KSLR, and now, but we don't want JDB as well, we want JDB better, and we said that, I just target, oh wow, lost my, what was, oh it's a mode, I think, what was the target mode, I actually forgot the syntaxes. Target mode with the chatting. Oh yeah, we're good. Now we want to actually break at some functions. So let's start writing down. It's time to actually start writing down some stuff. I'll call it building the exploit. And now in building the exploit, we want to break at certain functions and see what happens there, right? So one of the essential functions we want to break at is, we want to break at this cool one that we want to break at. So I'll just write it down here. Break at, and then end. We want to break at the destruction function. But we actually want to we'll see. We'll explore it a bit and we'll see what we're actually is happening here. Yeah. The other one is 100% the destroy one. We definitely want, or like even not the destroy one. Yeah. I don't even know about this one. The expression this time maybe one. Maybe. But if this is triggered, we know that the other one is triggered as well. So I can just pick this one, just to make sure that it's getting destroyed. This could work out. Cool. This could work. Okay. One small thing. I need to restart. I just realized I didn't put any breaks. Nothing. Set element expression allocate. First one, then NFT lookup destroy, and I want to see if those are being called, and then I'll actually try to get the address while debugging, stuff like that. This would be cool. This would be something really cool we can do actually. But we target to that, do this, and now we do exploit. Huh? This other expression. Have a problem here. An actual problem.
Why does it not hit it? Maybe something happens earlier actually. But this is the one that's been called if any expression is being added. Why would it not reach it? Okay, I'll break also this one. I have to expression it, but there is no way they don't they don't get reached. There is no way in hell they don't get reached. I accidentally activate caps lock. Oof. No, never mind. Even if it's not vulnerable, it should be hitting those functions. What is happening? Why is it not being initiated? Why is my expression not being initiated? Curious. I don't think this lists NF tables, right? Yeah, it doesn't. It lists on NF tables, which are basically netfilter, so it's not the same thing. Okay, so I have a problem here. It's not being initiated at all. And that's a tiny bit of a problem. What is the higher function? For example, this one, when I was being called from something, what is its higher function? Like something that initiates a rule, or an expression, for example. We need to take a look at that. Let's see what it's mentioned. It's mentioned in new set. Oh my goodness. I'm 100% that this one will be gold. There's no way this one is not gold. Eh? Oh, it's tables. New set. It has to be NF tables. New set. I'm making mistakes. Target first one. Okay. Adds the new set, the new name set. Right. Okay. Oh. Yup. I got it. Why it's not being called? Oh my god, I got it. It's because this is if you allocate an element, an expression in a set. I am blind. I didn't even read it. I'm dumb. So the entire thing about with the chains is fucking useless. Oh my god, we need to do a set creation. And add it to the set, not the other way around, not to the chain. Fuck. That's fine, I don't really care. It's easy to go up. I hope. Wait, just clear up a few stuff. Here. And we're good, and we're good, and we're good, and we're good, and we're good. We clear up this. No chain now. Cool, 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 cool. Add the set. Fine, we add a set. Some set with the set name. Cool, cool, cool. A row, we want to add it to the chat. Add, no, we don't add a row. We'll call it initiate lookup. I don't know how to call it. So this is what it will be called. And we take a table name and a constant, my brother, and a constant set. Now perhaps we can something. We need to play around more. This is kind of annoying. So our code just trigger your use after free. This is what it's gonna be called. This is what code set. Fine. You set up a set some shit. I don't care. We can copy over this, but we can do it. So yeah, this is a function that we are gonna reuse here. But we want to add the expression there. What is happening to me? Oh, 3 hours. Damn, we do be streaming today. Take a UF, and here we only need to create a I'm gonna call it throwaway, I think. This set that we create here throw away. This is a throwaway set, per se. But the interesting thing is we have set, which here is the persistent set. Set here is the persistent set that we have, and we added the set name we need to pass a family though. Here you need to do int 8 or like 6, I don't know, I don't care. Both work because it's small enough. And here we have just set, but we build it. This is tall because you need another thing here. You need constant char throw away name. Yeah, throw away name. This is just the bigger one. So here's a persistent that throw away is the one that triggers the use after free, basically. That is what we're doing here. And what else doing here? We have a throwaway set here, and we want to add stuff to that throwaway set, right? So how do we add actually stuff to that throwaway set? Well, we pass something to it, and what we need to pass is an expression. We need to add an expression. How to add an expression? Well, we gotta check in the tables. Have to find the set headers. But what does set what is the function that you set expression to? Take. What does take? Where is it? It's on this one, right? Is it? for each takes a set, takes data or an expression, turns data, or gets also more data. Doesn't seem right. Let's now search for expression. Let's see what uses expressions here. Add expression. Set an expression. Perfect. This is what we need. And now here in the doorway, we just do. Let's just set add expression. We give it the throwaway set. Right, this is what it wants, the set, and then an expression that we will want to set up. And we want to set up another lookup expression. So we're gonna get it in yeah, but we want to set up the expression without division. Sorry for the coughing. Sorry for the coughing, but here's what it is. Like I said, in the end. What the fuck am I? I'm spelling it wrong. Doorway. And here we just pass E. Boom. I think we have our trigger use after for function done. Should be. Have a lookup roofing, which I don't think we're gonna use again. So we just delete from existence. And we have only this. These triggers are use after free. With this set that we want to pass here. And add the expression to the set, to the throwaway set. And then we initiate the throwaway set. But that's the thing though. You gotta be here now. Have to look over everything. Because I renamed it doorway, but I didn't rename everything else. That's a problem. A little bit of a problem. Not in the other one. What the fuck am I reading? I don't even need this anymore. I'm not going adding any rules though. So much shit deleted from existence, damn. Throw away. I think that should be all mentions. I misspelled somewhere away. How do is it throw away? Wait. Here. Wait, am I dumb? Throw away. Yep. It's throw away. Here I misspelled it. I misspelled it at every possible location. Oof. And I probably misspelled it up here as well, right? Oh no. I just forgot to change it. We want to trigger. Wait. Trigger is after 3. Femi, sorry for the coughing. Femi, table name. We don't have such thing as a chain anymore. And a set name. And a throwaway set name. Chap throwaway 1. Misspelled it again. Throwaway 1. Throwaway 1. Misspelled it again. There is something wrong with me. Oh, those are warnings. I didn't pop. Interesting. Curious? I guess it does need that shit. I don't know. What am I doing? Yeah. We'll have just a global one, I guess. And we'll just up it every time. It's fine. Just have here int num. Set num. And then call it 0, 1. And every time we'll just do. Why is it? Sorry. We're going to set them this and this. Fashion not supported again. Interesting. What is it? How do they do it? They use the same thing as me. Set ID family, killing one, doesn't matter. No specific expression. Maybe this is what I need actually. Oh yeah, actually let's look at that. This might be very important. We didn't look at the flags of the sets. Because sets also have flags, right? How do we look at their flags? This is curious. Those are some attributes here. But there, here, they use NFT set expression. Which is this? What? No, but that's a netlink thing. This is just a flag. Curious. We're just gonna jump around more, I guess, till find something which makes sense. Here, Bobby, those are the flags here, right? NFT set and create a new set and num NFT set attributes. Those are attributes that we looked at just now. Set flags. You can set flags here. Could be anonymous. No. I wanted. It's not a map. You know, a set contains expressions. This already. Cool. What is it now? I don't even remember. What attribute is that? To what attribute do we pass that? The NFT set flags. Okay. I low-key want to know when I set the flags, what the fuck do I set them as? They're probably I fucked up something here. I don't think. Maybe it's not like that. What other things can I use? Here. Except like flags, right? Flags, I use the flags here. Oh, set element flags. But it's just set flags. Where did I find the element shit? What? I'm just dumb. I don't know where I found that shit. I don't know where I copied it from. I don't care. Let's go. Version not permitted again. Even though we have it here. That they shall contain expressions. Set key type. What is a key type? Key length, size of, I guess. Set name, set table. Oh. What is set? No. What the fuck do I use? I use the same thing. Excuse me? What? Sorry. Sorry again. No. There's some whispering in this. I was like, what? Is there a video in the background? No, there is whispering in the music. The hell? The hell? Why do I feel like some of these are incompatible with each other? Let's see, family, that's fine, that's fine. Healing, should be fine. Key type, 13. Should be fine. Set num plus plus. Should be fine. It said operation not supported. Operation not supported. Not permitted, but not supported. Which makes me think, why wouldn't it be supported? I don't know why I typed James. I don't know. Why would it be not supported? Could that be removed? No, but to be updated. What is not supported? Why do I have to use the type shit though? Just take some data, bro. Who cares? This is a problem, not the flag. When I set it to this, for some reason it's like, nah, bro, not making it. Why? Why are we doing that? Oh, could be the flag. Could be that the flag is not like rendered properly, like handled properly or something. Set flags. I just realized, do I have to import? Like, no, I think it's already imported. Maybe the way I'm adding set. Here, when you add set, create an acknowledge, fine. Here, create an acknowledge new set. Maybe it should have more. Perhaps they do it a different way. Nope. They use the same thing. Use a example to a T. Sorry for the cough. I can't do anything about it. I don't know. Looks the same to me. Maybe I'll just copy this. Then this is the. Okay, let's see what is different. Let's go by line by line. Table, table. Set. Set name, set name. Have a family, have a family. Have the flags, same thing. Have flags. Same, identical. Keyline, a little bit different. Okay, I'll just type 1 here. Let's see. I think it really matters. Oh, maybe it does. No, it doesn't. I just added that. Key type. They don't select key type. Move it. Set ID. Have a set ID. What was the without change? Was it this? I guess the key. It was the key thing. No. What? I tried removing that, but like. What? Has it been working this whole time? I just didn't like save or something? No? No way. Just wanna leave it like that, okay. That works. Okay, let's switch stage. Gonna mute myself while this is happening so I can eat something. Just realized it gives operation not supported because of the stateful flag. Because I don't have the stateful flag. I was so dumb. I was trying to solve that for hours. Not for hours, but for like 20 minutes. I was thinking about what the fuck is wrong. That is the reason. Now, it gave me a kernel panic and I realized it. Okay. So I get a kernel panic. Let's debug some. Finally getting to the debugging part. Like, we got once to it, but we had to write like almost every exploit. Exploit? Have a new set that's added. Okay, just gonna take a second. Just give me a sec. So I'm back. Had to call someone. Yeah. I'm back. Okay, what do we have here? This is a new set, and this allocates an expression, and this is the init function, and it's destroyed. It's used after feed. Perfect. It's exactly what we want. Now we can actually look at like stuff. The thing is, I should probably allocate it twice. Let's see if we can allocate reliability. No. No. It's free, right? Like, you can obviously see that we get a kernel panic. So our job now is to try to basically take off twice the user after free and reliably allocate a user K payload over the first one. Okay. We're gonna do some maths though. We know it's going to use KMLX64. Slab. However, let's look at stuff here. Actually, look at stuff here. How big is... How big? Okay. Oh wait, I want to actually do something first. Git add everything. And I will even push it maybe. Git commit m. Reliable... no. Kernel panic. Panic. CV. And let's push this. Oh my god, it might take some time because the whole file system is there. Never mind, I'm not gonna push it now, I guess. What are we doing? What is the size? What is the size of the allocated object that is being used after feed? Let's see. It's KMLX64 obviously, but how much? Does it matter actually how much it is? If it's KMLX64, no, it doesn't. But I want to know, so we're gonna check. We need all of those. I'm gonna copy them. Because it's going to always be allocated in the KMLX64 slabs, which is actually the only thing we care about. But we have just 8 bytes. I don't know how many bytes. This is 8 bytes as well. This is a byte. 1 byte. Wait. 1 byte. 1 byte. 1 byte. I think this all, even though it's a boolean, I think it takes also a byte. I think. Three, 5. Bytes, 8 bytes, 4 bytes. So I have 8 plus 8, 16, 17, 18, 19, 24, 16, 40 plus 12, 52. Perhaps 52 bytes. Perhaps 2 bytes. For sure KMLX64 though. Okay. If I'm not mistaken, now, wait, it's here. I saved it in my personal. This tells you more about actually, because I was wondering some Slabo exploitation. I'll call it Slabo exploitation. I was wondering something yesterday about if there is metadata in the slabs, because I actually didn't know, because I haven't done necro or what to use after face stuff. And yeah, there is not. depends on implementation, but slab and slab implementations, they don't actually have metadata after each slab. They're just one after the other. For example, the 64 one, like, yeah, doesn't matter actually. Let's just continue. I think I might be streaming like 40 more minutes, maybe 50. My goal is to leak a heap address today, I think. And I think I'll end stream after I leak the heap address. Even though I want to continue streaming, just probably have to end stream so I can do other stuff. Perhaps 52 bytes, for sure KMax photo. Okay, so that's what we have here. Now, we want to allocate at the same place use a key payload. Use a key, not key, use a key payload. How can I make sure? Wait. I'm thinking about something. No. Okay, it's in the off thing, I think. No, doesn't matter. I was thinking, how exactly do we even allocate the user key payload? Like, what code do you use? Wow, isn't that low-key unethical? Like, it's not actually unethical to like sit on for a long time on the vulnerability just for the cash price. I don't know. Seems kind of unethical. I also want to take actually look at this vulnerability as well. Maybe we'll do on stream. Pretty much it sounds like same shit, almost. I should probably be pausing it here though. That's why I made the Steam profile. So, I'm looking for a way to allocate reliably. Because here with Tigger, you have ones and then we can trigger it second time. That's another location though. How to? They're called keychains, right? Keyring, not keychain. Called keyrings, right? Okay, so use this. Cool. I'm gonna collect. What is it done? Turns a key serial. So I'm gonna return a key serial. Forge. User key payload. I guess this is forges as a user key payload of a const of a with a certain payload perhaps, or a certain the payload here. It's a pointer. I think. Can you read from a key? That's adds the key. How do you read from the key? Add key? Now have request key. We added a description, which is gonna be the name here, the description basically. And eh? This music is getting a little bit annoying, not gonna lie. How can I want something else. Time to check. PPI top. PC still not very happy about it. Yeah. Forge user key payload. Now, this is not easy. It's not hard, but it's like a little bit complicated. You add a key basically. So this takes a description, which I'm gonna pass as a constant char. Description. I don't know, I like this. The way it's like. I don't think the payload matters, we might extend it to matter, but the billion for sure matters, right? Size t billion, and the type is always user. Okay, so now we make a call. We do key serial key and do a call to that key and type. Did I include the key utils? Now we add the key, type user. Okay, type is user. Description is description. Billion is billion. Then we have payload. Okay, just a buffer. Some buffer. So we have payload, for example. So just some payload and just let's do this. Then we have like you do a void cast, I guess. Do a void cast, and then we have billion. But we have to have a keying. How do we add a keying? What happens if I don't provide it with the keying? Can I not provide it with the keying? See notes. Why would I? No, I don't need that. I don't think I need that. Keying IDs. They specify the comma's thread specific keying. The process specific. The comma's I don't think that really matters. I'm gonna use it specific keying because I don't want to fuck it up. So like this. Oh, what happened? Okay. Nothing? Yeah. Queuing. Have this. Okay. Now this is just a key. Just a return key. It shouldn't be that easy though, should it? I shouldn't just be able to get a key with a certain size this way. And what is even feeling here? Like, if I look at the user key payload, what size is it? This is 8 bytes. 2 bytes. 964 though. So we have 6 bytes more. You know what? I just copied this. I just copied this and work on it a bit lower because I don't know, like size of user key payload. 16 bytes. 2 bytes. 6 bytes alignment. So it's 24 bytes. 24, 64, 24. Bonus. 40? I've probably allocated 40 here. Is it 40 though? I don't know. We'll see, I guess, when it comes to it. To allocate the key payload with this key, key1, and twin. GCC. Wait, what if it doesn't have QTOs? I just... Wait, do they use QTOs? What do they do? I just realized. No, they don't. Oh, that's even more interesting now. They use just that key CTO one. Oh. Oh, this is the content, yeah. They handle the system calls themselves. Oof. That seems a little bit extreme, but I guess it's the only choice. They do handle them themselves. Maybe there is a function for that though. Like maybe guess some, just. Okay. So this is not like I cannot. Hmm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, I don't want a new key. I just want. Yeah, I want just a new key. Okay. Adding a whole world system call to the Linux kernel. What is this? No. Fuck. See. Linux kernel, I forgot. See, Linux kernel, add new user key. Like, perhaps, please? Ugh. What am I? We're just gonna rip it from them. As did the Ovio. Because why the fuck not? Why the hell not? Just rip it from them. I probably want to like add key. Type is user here. Just type, just say it's user. Have the description which pass here. Have some payload, payment, and wing ID. I was going to set it to a certain wing ID. I forgot which one. User keyring. This one. What is? What I am? Oh, okay. I think this is fine. Mostly. This should work fine, right? Just see. I guess. I don't know what this returns, maybe. But it does return something. What does syscalls return? Let's see. Like they return like what? Wait, I can just look at here. What is the weak symbol? Then what is the problem with me doing this? Key CVE weak, I guess. I have to add the Opa. Oops. Oops. Opa. I guess there's a key CVE isn't undefined in this case. I can rip it, I guess. I'm here. The user keying is -4. Specify -4. What else do we have here? I want still a string. What is this? The key CVE wants. just int 32, I guess. Question mark? I don't need this. Just say. Fine. Wow, but now would it actually add the key? Oh no, I even add the key. Can I add the same key twice? Interesting. My music is getting a little bit. Is my PC doing okay? What is using 100%? No, I want to order by CPU. Like, OS is doing significant amount, but I guess all of those tabs. I'll just open them again if I need them, I guess. But they don't actually handle. They don't. Nah, they don't need any CPU. They just go to like. They might clog around, but not CPU. I don't know. I don't care. This is we got a key payload here. The question now is this get allocated over? What do we want to get over? To get allocated over. And I think we might even create a function which actually allows us to read this and just like print it. I might. I hope I'll be able to finish it, like, probably not, but my hope is I'm gonna be somewhat close in 10 minutes to finishing it, like the heap leak. But just getting this is cool. Then now we need like another thing to actually read it, you know? Yeah. Let's look at how it's actually implemented here. How do you actually? Can I just? They probably copies from user, right? This payload. Probably, right? No way it doesn't. I don't know. How do you read it? Oh, this is the fuck. It's just going there. I was like, weak? Yeah, that's why. Oh! I'm gonna use this. But this is the key CTL thing. Huh. And that uses this. Okay, very interesting. Very interesting usage of those. I don't know why they use so many, like, I don't know. remove the weak. I don't want that weak. We wait here. We just delete from the item that gets returned here. This should return us key CVE-2, right? I think so. So we just say that this is a key CVE-2 leak key. Quite leaking. And now we have leak key equals no, just have a leak key here. Now the key CT let's say it's 40. So I'm gonna have a buffer size 40. Wait, buffer. My PC is studying CVS. Not as much anymore actually. I don't know. Try to like read buff is key still read leak key. Oh no, what am I doing? That's what am I doing? Okay. Hmm? Let's see. Perhaps. Forward Damn. This shit would be a nightmare to upload to YouTube. It's gonna be such a big file, and I don't have to end of it because I don't care. So. Still waiting for this. Yeah. Will we be able to read that heap address now? Will we be able to do it? Let's see. Come on. Do run now. I just realized something. I didn't allocate the second fucking object after this one. Actual tropic, and I shouldn't be exiting on this. Never should be exiting on this. Oof, nothing. I'll at least remedy my mistake. Here on Kistio. Read. Before we start reading. After we do the wiki stuff, we want to trigger another family. Use table 1. Table 1. Set 1. But we want to use a second. I have to this here now. What did I do? Why am I writing? Oh my god. I'm outparenting and it's not going well when I do that. I think this should be fine. I have throwaways. Create one here, you have here. Read format. Heap address output. I remove the here the failure of the simple one. I don't even think I should be move. I should move this here. Oof. Yes, web stage. Okay, come on. Ooh. Oh. If we start corruption, previous next should be next. True. But was something. Previous next should be next. That's when it's removing from the... No, from when it's adding to the list. Huh. Interesting. I'm kind of interested in where everything's getting allocated. I'm gonna be ending stream in like 30 minutes. But in those 30 minutes, what we're going to do is basically we're going to be debugging a little bit, get the address, see where everything's allocated, you know, and work from there. Yeah, this is basically what we're doing right now. Let's go. So we start this, and before we're actually gonna tag it first. But now we need to set appropriate breakpoints. And what are some appropriate breakpoints? Do you have any breakpoints? Just a second. Okay. Some appropriate breakpoints and what else? Where everything is actually. We want to break at the exact point where everything is getting allocated so we can get the address from there, you know? The heap address. And we can do that by where's the function that actually allocates the expression in memory? Is it the, which one is it? Wait. They're here. In NFT okay. So do disassemble NFT expression init and then just break at the one that actually issues a game alloc right here. Break it. Break this. It's 45. Yep. Breaking here. And this is one of the points we want to break so we can get the heap address. But then we know that another function not from here that a function allocates the keyring. I want to actually look at that function and find out. Wait, the user prepass allocates it. So I want to break there as well
disassemble. Break here as well at plus 45 again. Funny. Now to continue. Do root, do exploit. New set. Some new set stuff. Location, and we have init here. This is the NLP, and then it's the kmalloc. And this kmalloc now is going to be executed, and in ARX we see the heap address. Perfect. I'm gonna open and get it right here, and we're gonna write this one down. F8 D1E40, and now we do x10x. Oh, like actually want to do how big is it? 64. So 8 words, 8G. This is the allocated stuff. To continue. And as you can see, what is it called? What is this address here? Is it an address to ops? The first thing here should be a pointer to an ops structure. 8807F 8807F81. Oh, maybe that's just an object. Input symbol. Yeah, that's just some another symbol. It's not. Yeah, it's just. I got it. It's predefined. Yeah, it's the lookup ops. Okay, so this is where it's allocated. That's cool. And now, after we do execute, like actual VOD, you know. Okay, I'll just continue here. Okay. 1640. Oh, it's not the same one. Because I think something is allocated at the other one. What could be allocated there? Fuck. Something that contains this data. Fuck. Something has been allocated. Something zeroes it down and then allocates another place there. But is it the same page? It is the same page, right? Yeah, it is the same page. 8788T
one. Yeah, we know it's the same page. But it allocates a few objects down, I guess. Allocates it at 1640. Like a few objects up, actually, not down. What are those? What are those? What the hell? What the hell? I don't know. What could be allocating? Could be allocating there. So it fucks up our shit. It's kind of disappointing. How do we make it so that doesn't happen? I'm gonna restart. Okay. I think I wanna wait 3. I wanna like track what happens after that. Expression destroy. Break add empty expression destroy plus 45 again. Wow. Do the belonging to put them at 45s. Okay. Eh? What happened? It was not hit. Why was it hit? What the fuck? It first destroy. It should at least hit the 3. Wait. It gets. But it did not hit the 3. Huh? Maybe just the maybe it's yeah, I think that's what happened. It's exported as a separate function technically, but it actually just constructs it into this one, and this is actually the call that frees it, not other one. That'll be cool, or like interesting. Not to be. Wait, what am I doing? Break and nft set lm expression allocate plus 1 to 8. Just make sure. You always make sure. Plugging that everything is correct. Yes, yes. Now the K3 is about to get hit. And we're fine. The K3 gets hit. We're still fine. We need to actually see what allocates on this. Maybe I can break at Kalak. At Kmalak. Okay, at Kmalak. This would be a very question mark. Okay, fine. If you allocate here, it would definitely not allocate on the other place, right? What? I said next instruction and it sent me to like, where did it even send me? Where did it even send me? What the fuck? Why does it? Oh, because I jumped in the game. Like I got it. Now wait. Okay. It allocates it basically on the same page. Allocates it basically on the same page, but I've like a little bit too far, and for some fucking reason, something gets like writes over. Oh well, shit. That might actually be allocated. JDB, how to check if something's allocated. Wait, JDB. I don't like that. Like, allocates it close, but not on top of each other. And I feel like something else gets allocated there. I'm trying to figure it out, but wait, let me see if I'm doing something here. Basically, I took the UAF, and after that, I allocate this Malak. But when I took a Malak's, there's like Cisco. What flag does it use? Does it even? I don't know. I have to check. When Malak from user space, what GFP flag? Okay. They just have GPU user. Fine. Makes sense. Then why? What the hell? What is happening? Why is something allocating over it? Is this 40 too big? Is there like some kind of like real metadata? Did I miscalculate? Because let's look at it. This is 16 bytes. This is 2 bytes. 6 bytes alignment. And you have data. So 8, 24 plus 40. But even if that, it's something else gets right on top. Boring. Can I watch another? Yeah, I can. Okay, so I just watch the address and see what changes it, right? That's what we're doing right now. And when I do that, if I figure out what does it, if I could easily solve it, I'll solve it, or I'll leave it for tomorrow, whenever it's doing again, like whenever I finish this exploit. What am I writing? I'm tired. Actually tired. Why did I didn't want to do that. I just wanted to. Now I want to. Points. 09. I don't want. Yeah, that's too much. Favor Malak. No thanks. This one. Okay. It's our address now. Watch it. Watch this address. Continue. Here. Something changes here. Fine. Looking to destroy it. It goes 3 on it. But if you actually look at it, 88G, it's still stable, it's still fine. And here, copy user generic unload. Fuck. I don't know what causes it. Copy user generic unload. This is what fucks up with my sheet. Copy user generic unload. What the fuck do you do? Copy user generic unload. Copy user generic unload. Okay. Is it not documented at all? I don't know if you can hear my AC. Sorry if you can. I don't know. What did I do? I wanted to search for it. I just clicked the first one, which was this one. Memory copy with exception handling. Copy user generic unload. What? FDI switcher in this case is my address, and FCI is fucking source. What the hell? The source, which is this one. What is there? G X then G. What is this? C Can I? How? How can I look who this memory? What process this memory belongs to? It's from. I just realized it allocates it. I just saw the way to. It fucking allocates it. My second throwaway shit. Why does it do that? Why? Here. Why does it do it then? I guess it decides that soon I'll need it or something? Holy shit. Are you breaking my code? I have to imagine if I move this and it actually fixes itself magically. It does like shit with my 2054 throwaway. It starts copying fucking throwaway into my buffer. To my fucking buffer. Oh my god. But why does it do that before I even trigger the keyring? I haven't gone to the keyring yet. Haven't hit user prepaths. What the hell? What the hell? Yeah, I don't know. We'll figure it out. I moved it here. I don't think this will fix it. But I moved it. Wait, what if I don't allocate any heap memory? I think it's still get copied to the heap. What do they have this problem? How do they handle this? They just supply it here. They don't initiate. I guess this is the way. This is actually the way, maybe. Oh, delete both. Both this one, this one. Not existent anymore. And now I just do this. This is the way, I guess. In 10 minutes I'm stopping stream. Yeah. It's getting too long. 5 hours. Way too long. Two viewers, another viewer. Who's it? Who is it? I immediately spotted you, whoever you are. What basically we're doing right now is we have this vulnerability, which is a kernel vulnerability in netfilter, right? And it's a use after free. And I've been streaming for 5 hours, and I have one more stream for 2 hours. And in those 7 hours, basically looked over the vulnerability, how it was supposed to exploit it, and now we are trying to exploit the first part of it, which is to make a heap address from it. And that's pretty much it. Right now I'm waiting for it to build. And you left, whoever you are. You left. Yeah. What is this? Chat highlights? Okay, let's go. Fucks it up a bit. Does it do the same shit again? Let's see. Target. Okay. Continue. Wait. See. Exploit. Let's just see what hits it again. Just kind of interesting, you know. So I have here 888900. Okay, this is now it, right? I forgot to watch point it, but doesn't really matter because you can see something happen. Okay. Watch, and we'll watch point this one. Now we do continue. Freeze it. And this fucking copies the throwaway name into it again. Why it decides that it should no, it doesn't even say that. What the fuck is it doing? I just realized it uses the one. Huh. Allocated over the same one. The second expression got allocated over the same one, not the fucking key. Huh? And I know I'm gonna check now. Last thing I'm going to check here is how big those C stuff is. Because I'm maybe thinking it could be something from the user key payload, but just allocate it weird. I don't even know. No, I couldn't. There is. Fuck. I want to kind of solve it, but I'm not too tired to solve it right now. Okay, forge key payload. It allocates something key. But billion, maybe billion is too high. Maybe it should be like 35 or something. I don't know. This is triggering. Oops. didn't get it. Like something from the payload fucks it up before even the payload gets allocated on top of it. Like a separate thing when it copies from the user. Okay, I'm just going to read the stuff for a little while, for a second, and I will try to see how they do it, and if they avoid that some way. They spray keying here. Start. No. Key description max size. What do they believe is that? Key description max size. 40. Understandable. It is. Add key. That a user key. String well. Huh. What? What is the user key stuff here? Type description. The first one is type. Have description. Then payload, typical, playland, and then they pretty much do the same thing I do. SM printf. String. Size. Format. And yeah, that's pretty much it. They set some description there. Description. Yeah, wait. Why don't I do that? I just realized. Okay, one quick change and we'll see if it works. Why do I allocate a payload like that? Why don't I just do payload 40? What the fuck? Payload billion. One last thing. Payload billion. Just quick 5 minutes to waste on it. And yes. One last thing. Here. Some key payload. That's what I'm saying. I don't think this will change anything. I don't think this will change anything, but it doesn't hurt to try. 5 hours. Damn. Okay. Fuck. Okay. Just looking over it for a second, and I'm ending stream. Final ending stream. Wait, first info watch points. Target. See? Exploit. Oh. Where did I jump to? I typed next instruction, it fucking sent me to like... I hate JDB. I got yeeted. Some fucking... I don't know. Annoying. Step, perhaps? No, I don't want to go into it. I want the next instruction. Is it fucking dumb? Does it not realize what... Okay, I understand. Gonna type the step, I guess. Gonna step to it then. Cause... Fuck it. Apparently it wants me to do that. Oh my god.
guess I need it to be really small, but why the fuck? Okay, so I'm ending Steam. But conclusion from this stream. Let's write it down. Conclusion from this stream. Conclusion from stream. No, that's not right. It goes here. Conclusion from 5-hour stream. Allocating almost reliably. However, instead of the key object being allocated at location UF1, it is the name of the key object. Figure out that, and you figure out how to leak address. Okay. So this is the stream for today, basically. I'll probably be uploading on YouTube again. I don't know how long it will take, but yeah. This is the shit. So it was a pretty good stream actually. We researched like a lot of stuff, basically how to escalate, and then I started writing the exploit for a few hours, and we got somewhere. And Yaku, to a point where we almost have it. Almost have the heap address weak. But yeah, I was tired for like the past 2 hours, so stuff was moving kind of slow. But next time I'm confident we'll keep address in KSLR, and perhaps the next stream after, like the next after the next, we'll be able to escalate, I hope. So yeah, that was for me. Bye to all the 0 people watching.